back to this channel. So today we want to explain numbers. One of the mathematical skills that a child must learn in his or her earliest life is the counting of numbers. You start from 1, 2, 3, 4 and so on. So those numbers, we call them counting numbers or natural numbers. So if you are asked to define natural numbers, you just tell them that natural numbers are the counting numbers. That is 1, 2, 3, 4 and so on. So these natural numbers are denoted by, just write capital N, then you put another slash here. So natural numbers is a set of counting numbers. Natural numbers equal to 1, 2, 3, 4 and so on. Now, if you now include 0 to it, so you have 0, you start from 0, 1, 2, 3 and so on. This one makes whole number. So they are whole numbers. Yeah. There is need to develop mathematical idea beyond this fundamental arithmetic. That is when we can include positive natural numbers, negative natural numbers. Then those numbers that consist of positive natural numbers, 0 and negative natural numbers are called integers. So these integers can be divided into 3 parts. We have positive integers, so we have 0 and negative integers. So now integers can be denoted by capital Z, then you put slash at the middle. So when you are talking of positive integers, you write it as capital Z, put slash, then you put plus at its edge. Then for negative integer, you write capital Z, then you put negative there. So now let's talk of rational numbers. If you look at the word rational, you can see we can deduce ratio from it. Then plus 9. This ratio means you are writing numbers, natural numbers in form of fraction. So we can now define rational numbers as the numbers that can be expressed as ratio. So if you have A divided by B, where B is not equal to 0. And this A and B, they are natural numbers. So but the denominator must not be equal to 0. If you want your number to be valid, the denominator of a fraction must not be equal to 0. So that is, if we have 2 divided by 0, it is undefined, an invalid number. So, and this rational number can be changed to decimal. If it is changed to decimal, those decimals should be repeated or terminating. So if you write 3, you know 3 can be expressed as 3 divided by 1. So 3 is rational. Is a rational number. So can have 2 divided by 3. 2 divided by 3 will give us 0.6 6, 6, 6, and so on. This bar means it goes on. So this is repeating decimal. Also, if you have 3 divided by 4, this one is 0.75. So this one is a terminating or terminated decimal. So any number that exhibits all these properties, they are called rational numbers. So and rational numbers can be denoted by numbers can be denoted by capital Q. Then you put in summary, rational numbers are the numbers that can be expressed as ratio A divided by B, where B must not be equal to 0. Then its decimal equivalent should either repeat or terminate. However, those numbers that do not exhibit all the properties of rational numbers, they are called irrational numbers. Example of irrational number, we have pi. And this pi is 22 divided by 7. Why is it an irrational number? Since it can be expressed as rational, as fraction. We have its numerator as 22. We have a denominator which is not equal to 0. So why is it now an irrational number? So we explain that in the next video. So we have E. Then if we have square root of all prime numbers. So square root of 2 is an irrational number. Square root of 3 is an irrational number. Square root of 5 is an irrational number. So all those numbers, they are irrational numbers. Now back to the major work now, real numbers. These real numbers now consist of all rational numbers and all irrational numbers. So if we draw a number line, you have the number line as this. So this center is a 0. This right hand side will be positive natural numbers. So we have 1, 2, 3, 4, and so on. So till we get to positive infinity. This infinity is not a number, it's just a symbol to signify that those numbers goes on like that. We do not know its end. We cannot put full stop there. So it goes on. So we have -1, -2, -3, and so on. So we represent that and so on this left right hand side as negative infinity. It means it goes on and on. It doesn't end. So here we can, at this side, we can have like square roots of 2 there. So you can have 0.5 here. So 0.5, which is rational, and so on. So these real numbers consist of all rational and irrational numbers. So this table to represent all the real numbers. So this table, at the middle, we have natural numbers. Then whole numbers. Integers, Irrational. So at this side of rational, we have irrational numbers. It means that rational consists of natural numbers, whole numbers, integers. So irrational numbers will be here. Just for you to understand it, irrational numbers. So now it is now real numbers that now consist of all those numbers. Real numbers. So, and real numbers can be denoted with this capital letter R. Then you put 1 in front of it. So we can just say that 1 is an element of rational numbers. So it means 1 is a member of rational, is a member of real number. So if you say minus 2.5 belongs to real numbers, and so on. So you can just say that square root of 2 belongs to real numbers, and so on. So if you say all this, it means this one means elements of or members of, member of. So all it belongs to. So that is that about real numbers. So in the next video, I want to understand why pi is an irrational number and square root of 2 is an irrational number. Till I see you in the next class. Bye bye and God bless you.